Man, it is hotter than Satan's Speedo out there. I'll tell you what. I'll edit that out of this video. It is an interesting Greek word, and we'll talk about in a second. Kuma. Waves. Yeah? I love talking about waves. Yeah? Interesting. What about like an ultimate wave video? Huh? Ultimate video about waves. Thought analysis. Descriptions versus explanations. Getting to the heart of the matter. Referring to the noumena as transcendent to the phenomena. Because human beings are only fascinated by phenomena. Phenomena. Remember that old Sesame Street drawing went. Phenomena means sprout or also to embryo. When we talk about sprout or embryo, we're actually talking about manifestation. Embryo or sprouts have a seed. Assume a seed is, of course, planted. You didn't see the seed when it was planted, and yet we see the phenomena as manifest. Something with a beginning. Something that has a beginning is by definition phenomena. It has a beginning in space and time, but nothing is in space because space has no properties and time is only a measure of phenomena, because if something is phenomenal, then it has mass and magnitude. And then, of course, necessitatively, it has a beginning in space and time, and therefore also an end in space and time. It's composed of something, and of course it's begat of something else. Typically, of course, it's composite. It's comprised of several things. So, waves, of course, are Cartesian. I don't know if you know, x, y, z coordinate. It has a beginning in time with a transverse phenomenon. When we talk about waves, and scientists, and the only reason, not the only reason, but the fundamental reason why I'm talking about this is that I have endless thousands of books on science, which is not really science at all. A bunch of episteme and books written by mathematicians who are in love with numbers rather than the actual explanation of something in itself, the esse of something, because no branch of science has ever defined the term energy. They've never defined what a field is, to their great chagrin. Yes, what is a field? I can't tell you what a field is. It's extremely telling that the most important things actually, such as fields and energy, they can't actually tell you what these are, and all of current deep theoretical physics, which is deeply rooted in quantum and by extension relativity, is based upon, by their own definition, their understanding of the nature of light, and they can't tell you what light is. They love to talk about the waves of light. Waves of energy, they'll talk about quantum waves. It's quantum wave function. What? There's nothing in nature or natura naturans that we could call quantum. For some reason, and I know the answer to this, Tesla, Faraday, Steinmetz, Heaviside, James Clerk Maxwell, these people got by of building all of our current electrical world and electrical grid without ever using or thinking about this imaginary word called quantum, because quantum has nothing to do with nature. Everything is either dielectric, magnetic, or the composite thereof, electrical. When you talk about gravity, which is nothing other than non-point source mutual mass acceleration, or dielectric acceleration, but everything's capacitance, resistance, magnetic permeability, or dielectric permittivity, but there's nothing in nature we could actually call quantum. And yet, the thing word wave and this imaginary word quantum, by the way, you could take any book and just insert the word quantum after every fourth word, and you'll sound exactly like a modern-day scientist, which is actually a mathematician. Something quantum wave functionality has a quantum interaction with the binary particles that are in quantum's juxtaposition. That's exactly how they sound. I have all their books, most of them. I know exactly the way they talk. They use this imaginary word to back up their nonsense. Nikola Tesla referred to these people as those who could think deeply but not clearly. And he also pointed out that insane asylums are full of people that are very deep thinkers but can't think clearly. You have to be able to think deeply and clearly to be a sane, rational thinker, as Nikola Tesla said, which of course is correct. No one would ever think that you were anything other than crazy if you said that you saw happiness walking down the street. It's like, who was happy? Like, no, I saw happiness going down the street. Well, what are you talking about? What? Who was happy? No, not who. I saw happiness. Well, it's just crazy. You can't talk about waves. Waves of what? Waves are a phenomenal Cartesian function with values of space and time that are perturbations of, in the case of fields, or of course they're ether perturbation modalities. In the case of light, in the case of magnetism, magnetism actually has a frequency. That frequency varies depending on the material, the thickness of the material, the Gaussian flux of the material. It's measured called L'Amour frequency. It's also too called gyromagnetic precession, and it actually has a lag. The typical gyromagnetic L'Amour frequency precession is something like 52.4 megahertz. That's the median one. But we're talking about field perturbations, and these, of course, are transverse circuits of the medium, which is non-Cartesian. We could say it's in counter space, we could say it is counter space, we could say what it actually is, the ether. But there's nothing in the ether. There are things that are ether perturbation modalities. I talk about magnetism in the ether. It's like, no, magnetism is the ether. It's just an ether modality. Like ice, water, and steam are all one and the same thing. They're just different temperature and pressure modalities of one and the same thing. What we're referring to here, of course, is anything that has a wave constituent is phenomena. There are different types of waves. We can call them longitudinal waves, which is scalar, which is what Tesla referred to as a death ray. You know, you can demonstrate a scalar by, I don't have a hammer here, but, you know, hammering on the back of, you know, this pencil. We have a wave phenomena like this, where wave or phenomena occur with a set frequency, but there are other longitudinal waves where, like me hammering on the back of this pencil, instantaneous action at a distance, where there are no transverse phenomena. It's rarefaction and compression of the medium. Is that a wave? By strict definition, it is not, but it actually is a wave. Rarefaction and compression can actually be called a wave where a cyclic gradient occurs. And of course, scalar is measured in volts per second rather than frequency per second. Ultra-high frequency, for example, of course, is where all frequency vanishes. Extremely high frequency, way above that of gamma radiation, of course, is where you have the manifestation of light. Called it humorously frozen light, or call it hard light. But where frequency vanishes, this is where the phenomenal component of light disappears, and therefore, too, also its temporal component. One thing science did get right is referred to a zero-time particle. They also too call it a ZTP, which is what frozen, or what I humorously call hard light, would be. It'd be a zero-time particle where there is no frequency itself. It's the dynamo of a fundamental particle. By the way, there's only one fundamental particle, because all free neutrons become protons after 17 minutes, and the idea of the electron does not exist. There's no such thing as an electron particle. The so-called discoverer of that, who is J.J. Thomson, said electron is one unit, the principle thereof is 1 unit of dielectric induction. There's no such thing as an electron particle. You can never explain wireless power induction with electron particles either, nor instantaneous action at a distance. Yet scientists today think that all energy transfer is the movement of electrons, which is impossible as observed in countless phenomena, especially wireless power induction. They can never explain it to you. And they'll say it's lines of force. Like, well, how do you explain wireless power induction? There's no electrons jumping from here to here. Yeah. You could have two resonant frequencies where the field is induced and power is literally transferred from here to here in a total vacuum. So that's lines of force. Well, force of what, by what, upon what? Lines are not things. Those are conceptual abstractions generated by human beings and human beings' consciousness. There's no such thing as lines of force any more than there is any such thing as waves. These are field perturbations with a set frequency. And the frequency tells you the power magnitude. Have you ever thought, and this is really important, it's something important to think about if you want to understand Mother Nature. Have you ever thought why the higher the energy, the smaller the spatial footprint? Because the smaller the space, the higher the capacitance. ultra-high energy light like X-ray and gamma radiation has a footprint infinite magnitudes less than that of, say, infrared radiation or visible light or radio EMR, because gamma and light and visible and radio, they're all the same thing. They're different coaxial circuits of what we conventionally call light. We call it EMR. These mean energy release. The energy release creates a ripple of the ether. Not in the ether, because they are ripples of the ether. And that is why there's this transverse, like if you have a little toy car wind up, because I have a piece of fabric set on top of this table. Have you ever seen a little toy car that's driven along on a carpet and someone hits the brakes on it and then the fabric bunches up? Where we have a release of energy from the car to the braking, which causes a compression in the actual medium where the actual fabric ripples and bumps up, creating a set frequency due to the transference of the dumping of that energy back as the medium, which of course creates a perturbation. There's other ways of dumping energy, which of course is longitudinal. This of course is Tesla's scalar. But waves are Cartesian and involve the release of energy. There is no such thing as a wave, and yet I have to roll my eyes every time I see these, and I try to avoid them in these videos on energy that actually talk about waves, and they reify waves as something. Waves. Waves are traveling, quantum waves. Waves of what? There is no such thing as a wave. These people have incorrect descriptions at that point, much less correct explanations. We're referring to phenomena in the dumping and release of energy, whether it be scalar, which would be longitudinal waves, which has a cyclic interval of rarefaction and compression, which we could call a wave cycle of energy, yet it doesn't have a transverse component. The transverse component of specific atoms, its wave component, since matter is, let's take hydrogen for example. Every atom has, depending on its isotope, there are different isotopes of different elements, has an interatomic volume measured in the radius of picometers. You know how big the bubble of the atom actually is. Like say hydrogen is this big, and the lithium ion, even though it only, I forget what lithium is above, of hydrogen, is enormously bigger. It actually has a wave function volume relative to the electrostatic dynamo that is that particular element. Of course, all elements are nothing other than compounds of hydrogen. Hear that dog barking in the background? There's another wave function. The dog is irritated, a release of energy. The dog is barking, creating a perturbation in the air. Because nothing emits out sound, I'm creating a disturbance in the oxygen and nitrogen. Nothing on this earth either emits sound, in this whole universe, nothing emits sound and nothing emits light. Whether that be gamma radiation, X-ray, visible, radio, nothing emits sound or light. These are disturbances with transverse phenomenal manifestations. In the case of the ether of coaxial circuits of light, we're talking about transverse electrical magnetic, and the higher the spatial component, the lower the energy. The smaller the spatial component, the higher the energy. This is the reason why, say, low energy infrared or visible red light, for example, has such an enormous, huge spatial footprint. Have you ever thought about that? Why do you think it is Mother Nature has a system wherein the wave phenomena of the energy circuit of light is so enormous on low energy stuff like infrared or red in spectrum light? Why is this so much larger? Bigger things are more powerful, right? Well, not in the case of fields. That's completely backwards in the case of fields. The reason why the spatial footprint is so much larger is because the energy is so much less. The higher the energy, the closer it is to ether homeostasis. Let me repeat that again. The reason why the spatial footprint on high energy light is so incredibly so incredibly small. is because that energy circuit is so high that it is unable to reach a spatial footprint very far divergent from ether homeostasis. And when it reaches a certain level, in the case of matter, it has no transverse component. Isn't that fascinating? You go from infrared spectrum light to, say, gamma radiation to matter. The higher the potential, the smaller the spatial footprint. The smaller the spatial transverse wave phenomena of the electromagnetic circuit, or the coaxial circuit of light. I've never come across, of the countless thousands of books I have on science and light, oh boy, I really have every book on light, that ever asks itself the question, why is it that higher energy light has a much, 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 much smaller footprint? And the answer is divinely simple. Yet I've never heard anybody ask themselves that question. Why is it the higher the frequency, the smaller the spatial footprint? And the smaller the spatial footprint, the higher the energy value is of that light, be it gamma or X-ray. Waves do not exist, but waves in nature, we're referring to the release of energy which causes wrinkle in the fabric of the very ether itself. But there are cyclic longitudinal waves which don't have a transverse component. They are definitionally still waves. We could say it's connotative rather than denotative. It was still definitionally they're waves in the case of Tesla's scalar. This is also too likely the reason why ultra-high frequency vibrations is able to release a greater amount of energy through the hydrolysis of water. You get greater output. I have not verified that myself specifically. Many countless claims about the water hydrolysis device, where it uses, I think, 20,000 hertz, that is able to liberate more release of hydrogen and oxygen to be split up than the value of the energy required for input of breaking up the oxygen from the hydrogen in the case of splitting up water. But all these branches of scientists just endlessly talk about waves, but waves are not things at all. And these people don't tell you what a wave is. They don't tell you what a field is. They don't tell you what energy is. Wouldn't you think that science fundamentally would be best served if they keep using the word wave over and over and over again, endless millions of times, all the time, to actually tell you what a wave is? Because wave is not a thing at all. It's no different than the Greek word kuma. The word for wave also means sprout or embryo, which just means phenomena. The manifesting of what was prior unmanifest. Like, say you didn't plant the seed. All of a sudden, a sprout peers up out of the ground. Something is manifest. So, from the Greek, the word wave just means manifesting phenomena. But manifesting phenomena of what? It's, of course, of the ether. Whether we're talking about waves of water or waves of energy circuits, we're still talking ultimately about the ether, because matter, through the reconciliation of light and matter, are fundamentally one and the same thing, since matter is nothing other than super high energy light. So there we have it, the most extensive discussion on the term wave, incorrectly used and abused by so-called science today. Thank you for watching. Have a lovely weekend.